Dear students, we are going to start 10th class physics chapter 10, that is simple harmonic motion. So our topic today is simple harmonic motion. This is previously you guys have learned what is vibratory motion, what is oscillatory motion. Now we are heading towards a technical term that is going to be simple harmonic motion. Simple harmonic motion is basically a special kind of vibratory motion. You can say but what is the difference between vibratory motion and simple harmonic motion? It comes in the form of a definition. A vibratory motion in which the body's restoring force, Fr, restoring force, and acceleration are directly proportional to the body's displacement. Is called simple harmonic motion. This is the complete definition. A vibratory motion in which body's acceleration and displacement are directly proportional to the body's displacement. For example, let us consider a simple pendulum. This is called a pendulum because there are other kinds as well, complex pendulum, compound pendulum, but this is called simple pendulum. It rests at original position or equilibrium position or stable position. When it is displaced from this mean position to an extreme position, and when it is released, it will not stay over here. A restoring force will act on it to restore. It will wants to restore this block to its original position. So here comes the restoring force. Now this displacement from mean to extreme is called amplitude, or basically it is a displacement. So this is denoted by x, you can say. So this restoring force is directly proportional to the displacement. This is the basic definition of simple harmonic motion. There should be a restoring force, there should be displacement, there should be a vibratory motion. So these are the terms used here. And secondly, acceleration. How acceleration comes? By Newton's second law, F is equal to ma, and since mass is constant, mass of the bob is constant whether it is at extreme or mean position, so it can be eliminated. So we can write F proportional to A, or here we can use this terminology here or here. We can say A proportional to X. We have replaced Fr by A because A is also proportional to F. So these are the two basic requirements for a body to have a simple harmonic motion. Then we use a negative sign over here. The negative sign is used because the direction of restoring force is always towards the mean position, whether the body is going away or coming towards the mean position. And secondly, the direction of displacement is always away from the mean position. Since these two directions, one restoring force, the other is displacement, these are in opposite direction. That's why a negative sign is here, used here. Same is the cases for acceleration. So these two are the mathematical definitions of simple harmonic motion. Or you can say these two are the requirements or conditions for a body to have a simple harmonic motion. So the motion of simple pendulum is basically a vibratory motion because it fulfills these two technical requirements. That's why we can also say that its motion is not only a vibratory motion, its motion is also simple harmonic motion. Okay, now comes the basic conditions for simple harmonic motion. These are the three basic conditions for a body to have simple harmonic motion. That is, then the first point should be the motion must be an oscillatory motion or vibratory motion. The body's restoring force and acceleration should be and must be directly proportional to the displacement and should be opposite in direction. These three can be called as the characteristics or properties of simple harmonic motion. It says that velocity and kinetic energy is maximum at mean position. How? Since when the bob moves from this extreme position to the mean position, it gains velocity. When it gains velocity, the velocity is maximum at this point. When the velocity is maximum, obviously the kinetic energy should also be maximum. When the bob goes away from this mean position, it loses its velocity. When it loses its velocity, it also loses its kinetic energy. So kinetic energy is minimum, or you can say zero, at the extreme position. Whether this extreme position or this extreme position. Whether there should be the opposite case for the potential energy. Since potential energy depends on the storing force, so it is maximum at the extreme position and minimum at the mean position. Since it has the capacity to move towards the mean position, that's why at the extreme position potential energy must be maximum, and in between extreme and mean position it should be having an intermediate value. So these are the properties of the simple harmonic motion. These are the simple examples of a body to have simple harmonic motion. That is vibratory motion of simple pendulum, then motion of a spring mass system. It will be the case which we will discuss in the second part. A spring attached to a mass, and this mass is pulled and released, it will also have a simple harmonic motion. And secondly, the example of a ball and ball case. This is a ball and this is a bar, and this ball is released, it will go towards this mean position. It will not stay here because of inertia, it will move away from it and it will continue moving between these two extreme positions. This can also be called a simple harmonic motion. So boys, this is all about